During the 100-meter sprint, Usain Bolt can reach a speed of 10 meters per second in about 2.3 seconds. So what is his average acceleration during that time? We have a picture up here. He's going to be running to the right. His velocity is going to get larger and larger and larger, and his acceleration is in the same direction as his velocity because he's getting faster. So both of those are going to the right, so I know I should get positive numbers for acceleration and for the velocity. So now we got to pull some numbers out. I know it says that during the 100-meter sprint, he does this, but he does this in less than 100 meters. That just happens to be the event. So that 100 meters is there, but it's not a number that we're actually going to use because that's not how far he's traveling during the 2.3 seconds that this problem is asking about. He does reach a speed of 10 meters per second, and that's going to be a final velocity because if you're at all familiar with the 100-meter dash, all of the runners start from rest. They don't get to have a running start when the gun goes off. So his initial velocity is going to be 0 meters per second. And we know that he does this acceleration during 2.3 seconds of time. And the question is asking, what is the average acceleration that he has during that time? So now we're going to pick the equation that does not have the distance in it because we don't know how far he travels during this 2.3 seconds. So the equation that does not have distance is VF equals V naught plus AT. The equation is not set up for acceleration, which is the thing that we want, so we're going to have to do a little bit of rearranging to get the acceleration all by itself. The first thing we're going to want to do is move the V naught over to the side because we always want to move pluses and minuses first, anything that's being added or subtracted. So the V naught term is being added to a term with A, so we want to get rid of that first. So subtract V naught from both sides to make it cancel over here. And on the left now, I'll have VF minus V naught equals AT. Now I can divide by time to get A all by itself. So what that means is the final velocity minus the initial velocity all over the time it takes him to do this gives us his acceleration. Final velocity is 10 meters per second. The initial velocity is 0, so minus 0, I can just not write it. And that's all divided by the time, which is 2.3 seconds. When I plug that into my calculator, I find that he would have an average acceleration of 4.35 meters per second squared.